Welcome back to Parmar Academy. Today we are going to discuss the rest portion of our chapter, that is carbon and its compound. So we are going to discuss organic compounds. Firstly, what are organic compounds? Organic compounds are generally any chemical compounds that contain carbon and hydrogen bonds. The organic compounds are those which contain carbon and hydrogen bonds. Organic compounds are covalent compounds having low melting point and boiling point. The melting point and boiling point of organic compounds are lower. We are having various types of organic compound. The first one is hydrocarbons, second is haloalkanes, third is alcohol, and the fourth one is aldehyde. Next is ketones, and the sixth one is carboxylic acids. Now we are going to discuss hydrocarbons. As the name indicates itself, hydrocarbon is composed of two atoms, that is hydrogen and carbon. If I talk about hydrocarbons, we can divide hydrocarbons into two categories. The first one is saturated hydrocarbons and the next one is unsaturated hydrocarbons. So what are saturated hydrocarbons? In saturated hydrocarbons, we are having alkenes. What are alkenes? Alkenes are compound having single bond. And in unsaturated compounds, we are having alkenes and alkynes. What are alkenes? Alkenes are those which contain double bond. And alkynes are those which contain triple bond. How? In case of alkene, there will be a carbon-carbon single bond. And in case of alkenes, there will be carbon-carbon double bond. And in case of alkynes, there will be carbon-carbon triple bond. So, saturated hydrocarbons have single bond and unsaturated hydrocarbons having multiple bond. Let's move to our next slide. Now we are going to discuss saturated and unsaturated hydrocarbons. Firstly, we have just discussed hydrocarbons are alkanes, alkenes and alkynes. Alkanes are saturated hydrocarbons, and if I talk about the definition, here carbon atoms are connected by single covalent bond. And the general formula for alkanes are CnH2n plus 2. And examples are methane, ethane, propane. How we can use the general formula? Let's see. Here the general formula is CnH2n plus 2. We are considering N as 1. So we come up with C1H2 1 plus 2. Here C1H4. Simply we can say CH4. So CH4 is what? CH4 is methane. Here carbon is having 4 hydrogen and all are singly bonded. Let's move to the next case. The next case is of alkene. And if I talk about alkene, in case of alkene, there are 2 carbon atoms at least. And they are having double bonds. Say, in case of alkenes, carbon-carbon double bond is there. And if I talk about the general formula of alkene is CnH2n. This is the general formula of alkene. Now again consider the value of N. Say I am considering the value of N is 2. By filling the value, we come up with C2H4. It means Carbon-carbon is having double bond and we are having 2 hydrogen with each carbon. This is the shape of our compound, that is ethene, C2H4. Now let's move to next case, that is alkynes. And in case of alkynes, we are having carbon-carbon triple bond. And the general formula of alkyne is CnH2n-2. Say we are considering N is equal to 2. We come up with C2H2 is 4. Here C2H4. It means in case of alkynes, here is carbon-carbon triple bond and with each carbon there is one hydrogen. So the examples are ethyne, propyne and butane. All these compounds contain triple bond. Let's move to next slide. Here we are going to discuss electron dot structure. What is electron dot structure? In electron dot structure, we are presenting outermost electrons of any atom with dots. Firstly, we are going to discuss the example of alkane, and in alkane we are going to discuss ethane. Ethane is what? Ethane is a hydrocarbon having single bond. In case of ethane, we are having 2 carbon, and if I talk about the valence electron, carbon is having 4 valence electrons. Say the valence electrons, these are the valence electrons of carbon, and in case of hydrogen, each hydrogen contains 1 electron. Same in that case. So if I talk about the electron dot structure, I am representing 4 electrons with 4 dots, and in case of hydrogen, I am representing it with cross. And same for next carbon. This carbon is having 4 electrons and each hydrogen electrons is represented by cross. Here, in order to complete the duplet, hydrogen is sharing the electron of carbon. Same here, hydrogen is sharing the electron of carbon. And by that, hydrogen is able to complete its duplet. Now let's talk about carbon. In case of carbon, carbon is having 4 electrons of its own, and carbon needs more 4 electrons. So carbon will share 3 electrons of the hydrogen and 1 electron of the neighboring carbon. Same in that case, carbon will share 3 electrons of the hydrogen and 1 electron of the neighboring carbon. And here is the bond. So in case of ethane, we are having carbon-carbon single bond. So this is what? This is electron dot structure of our molecule ethane. Let's move to next example. The next example is of ethene. As the name indicates itself, in ethene we are having double bond. In case of ethene, we are having 2 carbons, and we know that carbon is having 4 electrons in its outermost shell, and in case of hydrogen, hydrogen is having 1 electron. Same for that. Carbon is having 4 electron and hydrogen is having 1 electron. Now we have to complete the valency. Firstly, we are going to complete the valency of hydrogen. In each case, hydrogen is sharing 1 electron from the carbon. And here we are left with 2 electrons of each carbon that are unshared. And we need to complete the octet. So in order to complete the octet, carbon is going to share the 2 electrons from the hydrogen and the rest 2 electrons from the neighboring carbon. And same, in that case, carbon is sharing 2 electrons from the hydrogens and 2 from the neighboring carbon. Say this is carbon 1 and this is carbon 2. Here, in case of carbon 1, it is having 8 electrons. 4 electrons are its own and 4 electrons come up with 1 hydrogen, 2 hydrogen and 2 from the neighboring carbon. So we know that each bond contains 2 electrons. So by joining the electrons, we are able to form bonds. So in case of ethene, we are having carbon-carbon double bond as represented by electron dot structure of our molecule ethene. Let's move to next example, that is the example of ethine. And in case of ethine, we are having triple bond. If I consider the case here, in case of ethine, we are having 2 carbons. Again, each carbon has 4 electrons of its own and 1 electron will be shared from hydrogen. Here, hydrogen will complete its octet by sharing 1 electron from the carbon, and on the other hand, carbon is completing its octet by sharing 3 electrons from the neighboring carbon and 1 electron from the hydrogen. Same in that case. So here we are having carbon-carbon triple bond. And this is the case of ethine, where the triple bond is forming between 2 carbon atoms. Let's move to next slide. In the next slide, we are going to discuss the electron dot structure of our compound, that is cyclopentane. What is cyclopentane? Here, cyclo mean a ring and pent mean we are having 5 carbons. It means we are not going to follow the straight chain pattern. We are going to arrange each carbon so that we can get a ring. We can say this is 1 carbon, second, third, fourth and fifth. This is the ring form. So we are going to discuss cyclopentane. It means ring structure of 5 carbon atoms. And if I discuss about the ring structure, here we know that carbon is having 4 electrons of its own and carbon needs to complete its octet. In order to complete the octet, carbon needs to gain 4 more electrons. Let's see how carbon is completing its octet. Say this is carbon 1 and it has 4 electrons of its own. And the rest 4 electrons are shared by hydrogens and neighboring carbon. Here, in that case, carbon is sharing 1, 2. 2 electrons from the hydrogen and 2 electrons from the neighboring carbon. Same in that case, each carbon is having 4 electrons of their own and sharing 4 electrons from 2 hydrogen and 2 carbons. Now, let's move to next example. The next example is of cyclohexane. Again, as the name indicates, cyclo stand for a ring and hexane stand for 6 carbon atoms. It means we are having 6 carbon atoms that are arranged in a ring. Let's analyze the structure. Say this is our carbon 1, and we know that carbon is having 4 electrons of its own, and carbon is gaining 2 electrons from 2 hydrogens and the rest 2 from the neighboring carbons. Same in this case, here, here and here. It means in the case of cyclohexane, we are having 6 carbons and each carbon contain 2 hydrogen by the mean of single bond, and we know that each bond contain 2 electrons. So 1 electron is from the hydrogen and 1 from the carbon are shared in each case, and the remaining 2 electrons of this carbon will be shared with the next carbon. And collectively, if I talk about here, this carbon is able to complete its octet by sharing 4 electrons, 2 from the 2 hydrogens and 2 from the 2 carbons. So here each carbon is attached to another carbon by the mean of single bond. This is the structure of the cyclohexane. Firstly, we have to mention dots for each electrons, and then we can join the dot in order to form a bond. Let's move to our next slide. In our next slide, we are going to discuss the very important portion of this chapter, and that is naming of hydrocarbons. Organic compounds are having 2 names. The first one is common name and the second one is IUPAC names. What is IUPAC mean? What does IUPAC stand for? Full form of IUPAC is International Union of Pure and Applied Chemistry. Let's talk about the naming of hydrocarbons on the basis of IUPAC system. The number of carbon atoms is indicated by stem. Say we are having different number of carbon atoms and what we use for these carbon atoms. Firstly, in case of 1 carbon, we will use neet. If we are having 2 carbons, then we use ith. For 3 carbons, we will use prop. For 4 carbons, we will use but. And for 5 carbons, we will use pent. These all are what? These all are stem portion of our compound while describing the names. And if we are having 6 carbon, we will use hex. For 7, we will use hept. And for 8, we are going to use oct. And for 9 carbons, we will use non. And for 10 carbons, we are going to use dec. Again, these all are stem portion. Let's see how we can use these stems. Here, the nature of bonding in carbon atom is indicated by adding the suffix after stem. Next, what we need to do, we have to add suffix, where with the name of our stem that we discussed in our previous slide. And how we are going to give name to these suffix? Firstly, for single bond, we are going to use ane. And for double bond, we are going to use ene. And for triple bond, we are going to use ene. Let's discuss these 2 rules with the example. Firstly, consider this example. In this example, we are having 3 carbon atoms. And we know that for 3 carbon atoms, we are going to use prop. and each carbon is connected to another carbon by the means of single bond. So for single bond, we are going to use the suffix that is "ene". So we came up with propane. What we did, we just joined prop with ene. Prop is what? Prop is the stem portion for the 3 carbons, and ene is we are using for single bond. So collectively we came up with propane. Let's consider the second example. In second example, we are having 2 carbons. And we know that for 2 carbons, we are going to use, yes, we are going to use eth. And here, in this example, we are having carbon-carbon double bond. So, for carbon-carbon double bond, we are going to use suffix "ene". Collectively, for 2 carbon, we mention eth. And for double bond, we are going to mention ene. If I join them, we will come up with ethene. That is the name of our second compound. Let's move to next example. Here, in next example, we are having 2 carbon atoms. They are joined by means of triple bond. Again, we are going to give them name. For 2 carbons, we are going to use word eth. And here is a triple bond. And for triple bond, we are going to use the suffix that is "ine". So collectively, we came up with ethyne. So that's all is the naming when we are considering a stem and a suffix. Let's move to next part. Now we are going to discuss IUPAC nomenclature for branch chain hydrocarbons. Now firstly, what do you mean by branch chain hydrocarbon? Here, if I consider this example, in this all the carbon atoms are present in a parallel manner. And here, if I consider the another example, here I have joined a carbon along with the inside carbons. So what we include them? They are included as a branched part of a molecule. So we are having certain rules for naming as per the IUPAC system. The first rule is select the longest chain. Firstly, what we need to do is we have to find out the parent chain. Now, what is the parent chain? Say, if I consider this example, in this example, we are having 1, 2, 3 and 4 carbons arranged in this manner. We can also number this in different way. Say, we are considering, we are starting from there, 1, 2, 3, 4. This is the another way where we can do numbering. Now let's consider the another way. Here we can also do numbering starting from there. Consider this as a 1, this as a 2 and this as a 3. Now what we need to do? We have to find out the longest chain, and in this way we are having 4 carbons, and if we are starting from there 1, 2, 3, 4, again we are having 4 carbons, and if I start from there 1, 2, 3, we are having 3 carbons. So which one is the longest chain? We are having 2 longest chain. So we can consider any one from them. The next rule is alkyl group present as side chain are considered as substituent. Now what we need to do? We have to find out the substituent. If we are considering this our parent chain, then this will be our substituent. This is the alkyl group which works as substituent. And nextly, methyl group, say this is methane. If this is methane, then CH3 will be called methyl group. Here for methyl group we are using CH3. For ethyl group we are using CH3CH2. And for propyl group we are using CH3CH2CH2. Let's move to the third rule. What third rule says? Alkyl groups get the lowest possible number while numbering the carbon atoms. Now what we need to do? We have to give the lowest locant position to our alkyl group, and this is our alkyl group. So where we need to start our numbering? This is the first, second, third and fourth. This is the one way where we can do the numbering. Let's consider the another way. We can also start our numbering from there. 1, 2, 3 and 4. If we consider this case, then our alkyl group is getting second position, and if we are considering our numbering from there, then in that case alkyl group is getting number 3. So which pattern we have to choose? We have to choose that pattern where our alkyl group is getting lowest number, and that is from this side. So we have to start numbering from this side so that our alkyl group can get lowest number. The next rule is mention the position and name of alkyl group before the name of parent hydrocarbon. Now what we need to do? Firstly, we have to mention the number of the alkyl group, where it is situated, and we just discussed we are starting our numbering from there. This is carbon number 1, this is 2, this is 3 and this is 4. And our methyl group is present at second carbon. So we are starting our naming with 2. Now what is the name of our alkyl group? Our alkyl group is the methyl. So firstly we mention the number where alkyl group is present. It is present at number 2. Now we will mention the name of alkyl group, and our alkyl group is methyl. So we mention methyl. And after that we have to give name to our parent chain, and our parent chain contain 4 carbons, and for 4 carbons we are using bute. So here is the bute, and all the carbon are having single bond. There is the single bond situated in each case. So for single bond we will use ane. So we come up with the name, that is 2-methyl-butane. Let's move to next slide. Now we are going to discuss some example. Let's talk about the first example. Firstly, what we need to do? We have to find the longest chain. So 1, 2, 3, 4, 5, 6. This is our longest chain which we consider as parent chain. It contains 6 carbon. So for 6 carbon we will use the root, that is hex. And if I talk about bonding, we are having triple bond, and for triple bond we are using ion. So we come up with the name, that is hexane. Let's move to next example. Here firstly we have to find out the parent chain. Say this is first carbon, this is second carbon, and this is third carbon. This is the first possible parent chain where we are having 3 carbons. And we are having one more possibility, that is, consider it as a 1, this is 2, and this is 3. So we are having two different patterns. We can consider this as a parent chain or this as a parent chain, because in both the cases we are having maximum of 3 carbons. So let's say we are considering this case. Now what we need to do, we have find out the longest chain. Now we have to give name and number to our substituent. If we are considering this as our parent chain, so this and this will be substituent. And what is the position of substituent? Both are present at number 2. We are having 2 substituent and the number is 2 for both the substituent. So for that, firstly we mention 2, 2. This is for this one and this one. After that, we are using di. What does the word di mean? It means we are having 2 substituent that are same, and our substituent are methyl. So we are having 2,2-dimethyl. Now we have to give name to our parent chain, and we know that in our parent chain we are having 3 carbons, and for 3 carbons we are using prop. And if I talk about bonding, here all the carbon atoms are having single bond, and we know that for single bond we are using ane. So we come up with 2,2-dimethyl propane. This is the name of our compound B. Now let's talk about next example. In this example, we are having 3 carbon atoms, and we know that for 3 carbon atoms we will use prop. And if I talk about bond, here is the double bond, and we know that for double bond we will use ene. So collectively we come up with propene. Propene is the name of a third compound. Now let's move to next slide. Here our next slide is of isomer, and this is the very important topic. Now what are isomers? The organic compounds having same molecular formula but different structure are known as isomers. In isomers, the molecular formula will be same but the structure will be different. Isomer is possible only with hydrocarbon having 4 or more carbon atoms. If our molecule contain 4 or more carbon atoms, only in that case isomerism will exist. And if I talk about the molecules, say methane, ethane and propane, methane contain 1 carbon, ethane contain 2 carbons and propane contain 3 carbons. In these 3 molecules we are having less than 4 carbon. So for these 3 there will be no isomer possible. So we are going to discuss the example of pentane, and we know that in case of pentane we are having 5 carbons. How we can arrange these 5 carbons? Firstly, here this is carbon number 1, 2, 3, 4, 5. Pentane has 5 carbons. And if I talk about hydrogen, 3, 2, 2, 2, 3. We are having 12 hydrogen. This is the formula of our compound pentane, and the formula will remain for every molecule. What is the difference? The difference is in the arrangement. If I talk about this case, in this we are having straight chain, and each carbon is having single bond. So for straight chain we will say N-pentane. If I talk about this molecule, here again we are having 5 carbons. This is 1, 2, 3, 4 and 5. And again the number of hydrogen will be 12. So this is the branched part. And if I talk about the next example, same, here we are having 5 carbons and 12 hydrogen. Collectively, in these 3 examples, the number of carbon and number of hydrogen are same. But what is the difference? The difference is in the arrangement of atoms. Here, all the atoms are present in straight chain, and here one CH3 molecule acts as a substituent, and here 2 CH3 molecules are acting as a substituent. So these are different arrangement how we can arrange our molecule C5H12. If we talk about naming, for that this is the pentane. IUPAC name for this is pentane. As we just discussed, for 5 carbons we will use pent, and all are having single bond, so we will use ane. So the IUPAC name of the compound will be pentane. And if I talk about common name, the common name will be N-pentane. Let's talk about the next compound. Here, this molecule acts as a substituent, and while naming, we will start numbering from there. This is carbon number 1, 2, 3, 4. And this alkyl group, which is methyl, is present at the second carbon. So for that, we will mention 2. And in our parent chain, we are having 4 carbons. And for 4 carbons, we will use but. And all carbons are having single bond. For that, we are using ene. So the IUPAC name of this compound is 2-methyl-butane. And if I talk about common name, the common name is isopentane. Here, in third example, we can consider this as a parent chain or this as a parent chain. If I talk about the IUPAC naming, we will consider these as the substituent which are present at position 2. So the name will be 2,2-dimethyl because our substituent are methyl. 2,2-dimethyl. And in our parent chain, we are having 3 carbons. And for 3 carbons, we will use prop. And all are having single bond, so we will use ane. Collectively, the name of our compound is 2,2-dimethyl-propane. This is the IUPAC name. And the common name of our compound will be neopentane. Collectively, we have discussed our compound, that is C5H12. And the molecular formula of C5H12 can be represented with different structures. That's why these all are considered as the isomer of the formula C5H12. Now let's move to our next slide. Next is homologous series. Now, what is homologous series? A homologous series is a group of organic compound having similar structure and similar chemical properties in which the successive compound differ by CH2 group. Let's discuss in detail. Say we are moving from one hydrocarbon to another. Then what will happen? There will be a difference of CH2 group when we move from one hydrocarbon to the next. Firstly, we are going to discuss some characteristics of the homologous series, and after that we will see how there is variation of CH2. The first characteristic is any two adjacent homologous differ by one carbon atom and two hydrogen atom. Just as mentioned there, if we move from one hydrocarbon to another in a consecutive manner, then there will be difference of one carbon and two hydrogen. That makes CH2. The next point is here the difference in molecule mass of any two adjacent homologous is 14. This is the 14 unit. We know that for carbon we are having molar mass 12 units, and for hydrogen we are having molar mass 1 unit, and we are having difference of CH2, 1 carbon and 2 hydrogen. So for that the difference will be 2 units, and collectively the difference will be 14 units. Let's talk about the third characteristic. The compounds of homologous series show similar chemical properties. In chemical properties, we will talk about only certain reactions that are possible for these hydrocarbons. So, the chemical properties will be similar for homologous series member. Next, the member of homologous series show a gradual change in their physical properties with increase in molecular mass. Say, if the molecular mass is increasing, then what will happen? With increase in molecular mass, there will be change in the physical properties. What kind of physical properties? That will be melting point, boiling point. As the number of carbon and hydrogen is increasing, then there will be increase in melting point and boiling point. Now, let's discuss homologous series of hydrocarbons. Say, we are going to discuss homologous series in case of alkane, alkene and alkyne. Here, in case of methane, the formula for methane is CH4. And if I talk about ethane, the formula for ethane is C2H6. And if I talk about the difference between methane and ethane, the difference will be CH2. Same in case of ethane and propane, the difference is CH2. And in case of propane and butane, the difference will remain same, that is CH2. And we know that in case of carbon, the molecular mass is 12 units. And in case of hydrogen, the molecular mass is 1 unit. And we are having 2 hydrogens. So the difference will be of 2 hydrogens. So collectively, we came up with 14 units. So the difference between two members of alkane series is 14 unit. Same, if I talk about the case of alkene, the first member is ethene, and the molecular formula for ethene is C2H4. And for propene, the molecular formula will be C3H6. And in case of butene, the formula is C4H8. Now, let's see the difference. Here, if I talk about the difference between ethene and propene molecule, it is CH2. And the difference between propene and butene is CH2. So again, for CH2, we are having the difference of 14 units collectively. And if I talk about the another series, that is alkyne, in case of alkyne, we are having ethine C2H2, propyne C3H4, butane C4H6. And if I talk about the difference between these two members, it will be CH2, and these two members will be CH2. So, in short, if I talk about homologous series, the difference from one member of series to another member of the series will be CH2. Doesn't matter we are taking the case of alkene and alkyne. The difference remain same. Now, let's move to our next slide. Here we are going to discuss some important functional groups. Firstly, we are going to discuss the case of haloalkane. What is haloalkane? If I talk about the word, it itself indicates halo is for halogens and alkane is for the members of hydrocarbon series where carbon is having single bond. So, in case of haloalkanes, we are having prefix that is chloro-bromo. Chloro is for chlorine, bromo is for bromine. Say, we are going to discuss the example of haloalkane molecule. Here, we are having 3 carbon and 1 chlorine. So, how we can do naming of that? For naming, firstly, we have to mention a halogen group. In case of this example, here the halogen group is chlorine. So, for chlorine, I am going to use the prefix that is chloro. So, firstly, I mentioned chloro. And now, I am going to see the number of carbons present in molecule. And how many number of carbons are there? 1, 2, 3. So, for 3 carbons, we are going to use prop. And we know that all the carbons are having single bond. So, for single bond, we are going to use ane. So, collectively, we came up with chloropropane. In the next example, here we are having bromine as a functional group. And for bromine, we are going to use the prefix that is bromo. And if I talk about number of carbons, we are having 3 carbons. And we know that for 3 carbons, we will use prop, bromo, prop. And all the carbons are having single bond. For that, we have used ane. So collectively, we come up with bromopropane. Now, let's talk about the next functional group, that is alcohol. And for alcohol, we are going to use suffix that is -ol. And if I talk about the example, here we are having 3 carbon atoms and 1 functional group. So how we can do the naming of that compound? For that, firstly, we have to see the number of carbons present in our parent chain. We are having 3 carbons. For 3 carbons, we are going to write prop. And here, all the carbons are having single bond. And for single bond, we are going to use ane. And in the last, we are having our functional group for which we are going to use suffix that is -ol. So, while writing the name, we will write prop ane -ol. Here we have cancelled the E of ane because we can't write two vowels together. So the name of our compound is propanol. Let's move to next functional group. Here, that is aldehyde. And for aldehyde, we are going to use the suffix that is -al. Now let's talk about the example. Here, for aldehyde, we are having CHO group. If I talk about the example here, firstly, we have to see number of carbons. And here, in that case, we are having 3 carbons. And for 3 carbons, we will write prop. And here, all the carbons except our functional group are having single bond. And for single bond, we will write ane. And for functional group, we are going to write al. And when we will club, we will come up with propanol. This is the name of our compound where the functional group is aldehyde. If I talk about the functional group, I can write it as C double bond OH. This is the exact representation of aldehyde group. Now let's start with another example, that is of ketone. In case of ketone, we are going to use the suffix that is -on. And if I talk about the example here, same, firstly we have to mention the number of carbons. In case of ketones, we are having here 3 carbons. And for 3 carbons, we will write prop. And then for bonding, we will write ane. And for functional group, we will write on. So we come up with propanone. This is the name of our compound where the functional group is ketone. In the next example, we are having the functional group that is carboxylic acid. And for carboxylic acid, we will write suffix oic acid. And if I talk about example, here again, firstly we have to see the number of carbons. And in case of example, we are having 3 carbons. And for 3 carbons, we will write prop. And all the carbons except the carbon of functional group, we are having single bond. And next is our functional group, for which we are going to write oic acid. So we come up with propanoic acid. And here, this is our functional group and we can represent it like that. This is the exact representation for our functional group, that is carboxylic acid. Next is case of alkenes. We have already discussed the case of alkene. In case of alkene, we will use -ene. Why? Because in case of alkenes, we are having double bond. And the method will be same. Firstly, we have to mark the number of carbons. Here, in this example, we are having 3 carbons. And for 3 carbons, we will write prop. And here is our double bond. And for double bond, we will use -ene. So we come up with propene. Now, move to next example. Here, the next functional group is alkyne. And for alkyne, we will use -ine as a suffix. Let's see example. Here, in this example, we are having 3 carbons. And again, for 3 carbons, we will write prop. And if I talk about bonding, here is the triple bond. And we know that for triple bond, we will use -ine. So collectively, we came up with the name that is propyne. So this is all about the organic portion of our chapter carbon and its compound. For more updates, keep in touch with us. Thank you.